Yeah.
Hello, my name is Gerdien van Schaik. I'm coordinator of the STOC-free project. In the STOC-free project, which is EFSA funded, we collaborated with 6 countries in Europe to develop a tool for outcome-based comparison of the confidence of freedom generated by control or eradication programs. Risk of transmission of diseases is still existing in Europe, especially for non-regulated diseases through cattle movements. For non-regulated diseases, EU countries have diverse control or eradication programs. And these different control programs result in a different definition of the free status. And therefore, outcomes of those programs cannot easily be compared. And the degree of certainty about freedom of infection between those programs varies. So we considered that we needed a standardized measure to enhance safety of trade. The aim of our project was therefore to develop and validate a new tool that we called STOC-free that enables a transparent and standardized comparison of confidence of freedom for control programs. The project started in March 2017 and finished December 2021. In this project, we wanted to answer the question, when trading an animal, does it pose a risk of introduction of an infection into the destination herd? So what is the probability of freedom of that animal given the available information from the destination herd? We developed a framework which consisted of a data interface, STOC-free data, a model, STOC-free model, and of course the outputs, the probability of freedom, including uncertainty. We encountered several challenges. For example, the whole framework should be easy to use by stakeholders. We also had to deal with heterogeneous inputs, but we wanted uniform outputs that could be compared. We wanted outputs on different levels of aggregation, animal level, herd level, regional level, country level. In the end, we decided to stick to herd level only. And we used bovine virus diarrhea virus as a case disease because it's a complicated disease, and we figured that the framework would be easily adaptable to multiple diseases in other species when we managed to model BVDV. STOC-free data. About STOC-free data, there are already several publications of Annika van Roon, a PhD student in this project. They're all depicted on this slide. With the tool, she described the different control programs. She looked at different risk factors for introduction and delayed detection that we wanted to include in the model. And she created and expanded the questionnaire with which the data for the model could be collected. The STOC-free model should, of course, include the risk of introduction. It also assumes a homogeneous biological system of a disease, in our case, BVDV. The STOC-free model should be able to deal with heterogeneous sources of input information, in our case, the different BVDV control programs in the 6 different countries. And in the end, the output should be the probability and associated uncertainty that an animal from a free herd is truly free. We applied the prototype of STOC-free to the BVDV control programs in the 6 countries in our project. And we encountered many challenges. BVDV turned out to be a very complicated disease to manage and to model. And we also had to go back to herd level only because animal or regional level models would become very complicated. We gave some suggestions for generalization to other diseases and maybe even other species, which is definitely possible, but it was outside the scope of our project to do this already. So in future developments, we see STOC-free to be further developed into an easy-to-use tool. It's already available, and you can see in the other videos on this site how you can use it for BVDV, and we hope to continue with work so that it can be used for other diseases as well. In the end, in our vision, we see stock-free to be used by an independent organization that has access to data in the country of origin and feeds in the data necessary for the model to be able to determine the freedom of disease for a specific disease in a specific control program in that country, so that the destination knows whether trade is safe. We hope that stock-free will be used by every country or region that wants to evaluate probability of freedom of traded animal for any disease. And this is feasible within a cost action called sound control, in which 32 EU countries participate. In this cost action, the work of stock-free will be elaborated on, hopefully further, for other diseases as well. The use of the stock-free framework will in the end stimulate safe trade, improve biosecurity on farms, and with that have economic benefits due to the reduced risk in a flexible trade context. Thank you for your attention, and I hope that you have a look at the other material on this site to get to know more about the stock-free framework. Thank you.